Right now, an alien iceberg is exploding in our solar system. 3I/ATLAS, a visitor from another star, is erupting ice geysers into space. Scientists see the spiral jets, the mysterious patterns. But here's the problem. They can't explain why it's happening. Some say it's a cryovolcano. Others point to 14 unexplained anomalies that make no sense. NASA claims it's normal, yet refuses to address the strange behavior. What's really causing these ice eruptions? Let's dive right in. To understand what's happening with 3I/ATLAS, we need to start with a concept that sounds like science fiction, but is very real: cryovolcanism. Think about the volcanoes you know: molten rock, rivers of lava, explosive eruptions of superheated material. Now flip that completely. Cryovolcanoes don't spit fire, they erupt cold. Instead of 1,200-degree magma, they shoot water vapor, frozen gases, slushy ice, and methane into the vacuum of space. This isn't theoretical. We've seen cryovolcanism on Enceladus, one of Saturn's moons, where massive ice geysers spray from cracks in the frozen surface. We've observed it on Pluto and on distant frozen objects drifting beyond Neptune. It's rare, exotic, but it happens. So when scientists looked at the latest images of 3I/ATLAS from November and early December, they saw something familiar. The spiral patterns in the coma, that glowing cloud surrounding the object, looked exactly like cryovolcanic plumes, jets of material streaming outward in organized patterns, just like the ice geysers we've documented in our own solar system. The explanation seemed straightforward. 3I/ATLAS is an interstellar iceberg that's been traveling through the cold darkness of space for potentially billions of years. Now it's entered our solar system and is heating up as it approaches the sun. That heat triggers eruptions. Every 16.16 hours, as the object rotates and different surfaces face the sun, new jets fire off into space. It looks natural. It looks like something we can understand and explain. But the more you look at the details, the more questions emerge that don't have easy answers. Scientists didn't stop at just watching the jets. They analyzed the light reflecting off 3I/ATLAS, breaking it down into its spectral components to understand what this object is actually made of. What they found stopped them cold. The spectral signature matches old carbonaceous meteorites, specifically the ones we found in Antarctica. These aren't ordinary space rocks. They're loaded with metals and frozen gases, and their composition is nearly identical to trans-Neptunian objects in our own solar system. Those icy bodies that drift in the darkness far beyond Neptune's orbit. This discovery is profound in ways that are hard to overstate. If 3I/ATLAS shares the same composition as our solar system's frozen worlds, it means the process that created our icy objects isn't unique to us. Other star systems, orbiting other suns, are producing the same kinds of frozen bodies. The same mixtures of ice and metal and organic compounds are forming in stellar nurseries across the galaxy. We're not special. The building blocks of worlds like ours might be everywhere. That realization should excite us. It suggests that the ingredients for planets, for moons, maybe even for life, are common throughout the cosmos. But it also raises a troubling question. If 3I/ATLAS is made of the same stuff as our trans-Neptunian objects, if it formed through the same natural processes, why doesn't it behave like them? Why are scientists struggling to explain what they're seeing? This is where the clean, comfortable explanation starts to unravel. Because while some researchers are satisfied calling this a natural ice volcano, others are pointing to observations that simply don't fit that narrative. Harvard professor Avi Loeb has been documenting these anomalies, and they're not minor inconsistencies. They're fundamental problems with the cryovolcano theory. Take the brightness fluctuations. 3. I/ATLAS pulses like a heartbeat. Its light output rises and falls in a rhythmic, regular pattern. Natural comets vary in brightness as they tumble through space, but not like this. Not with this kind of predictable rhythm. It's as if something internal is cycling, turning on and off with precision. Then there's the acceleration. Every object in space follows predictable gravitational paths. When comets deviate from those paths, it's because they're outgassing. Jets of evaporating ice push them slightly off course. We can measure this effect, calculate it, predict it. But 3I/ATLAS is accelerating in ways that don't match normal outgassing patterns. The acceleration is too strong, too consistent, too controlled. It's as if the object is maneuvering rather than drifting. And that tail we mentioned earlier, the one that looks like headlights pointing forward instead of streaming behind like a normal comet tail, some researchers are suggesting it might not be a gas tail at all. It might be a swarm of smaller objects traveling in formation. If that's what we're looking at, the implications are staggering. Is this a debris field from a collision? Is it fragments held together by weak gravity? Or is it something else entirely? Something we don't have a framework to explain. But none of these anomalies compare to what happened at perihelion. 3. I/ATLAS changed course. During its closest approach to the Sun, when gravitational forces are strongest and trajectories are most predictable, this object altered its path. It's now heading directly into Jupiter's Hill radius, the sphere of gravitational influence around the planet. Run the orbital mechanics. Calculate the probabilities. The chance of an interstellar object randomly entering our solar system and just happening to redirect itself toward Jupiter's gravitational zone is essentially zero. It doesn't happen by accident. Here's what's frustrating for anyone trying to follow this story objectively. We have two groups of scientists looking at the same data and reaching opposite conclusions. One group sees a natural cryovolcano with some unusual properties. The other sees something that defies natural explanation. Both are looking at the same images, the same measurements, the same observations. But only one side is willing to address all the anomalies. The cryovolcanism proponents focus on what fits their model. The ice jets, explained by thermal eruptions. The rotation period, normal for a tumbling object. The composition matches known icy bodies. They're not wrong about these points. The evidence does support volcanic activity. But when you ask them about the heartbeat pulse, they go quiet. When you bring up the Jupiter trajectory, they change the subject. When you mention the acceleration profile, they suggest we need more data. Meanwhile, NASA's official position has been to call this a normal comet and move on. Their press conferences acknowledge 3I/ATLAS exists, confirm it's interstellar, and then treat it as routine. They haven't addressed the anomalies in any public statement. They haven't explained why the trajectory intersects with Jupiter. They haven't discussed the rhythmic pulsing or the non-gravitational forces at work. The silence isn't just noticeable, it's deafening. Avi Loeb isn't saying it's aliens. He's saying we can't rule anything out yet, and that the responsible scientific approach is to investigate all possibilities, including artificial origin. That's not sensationalism. That's the scientific method. You look at the data, you consider all explanations, and you follow the evidence wherever it leads. But institutional science often prefers comfortable answers over uncomfortable questions. Let's focus on what we can verify with our own eyes. The jets streaming off 3I/ATLAS are undeniably real. High-resolution images show plumes of material erupting from specific points on the surface, shooting into space in organized streams. These aren't random puffs of gas diffusing into the void. They're directional, powerful, and they fire on a predictable schedule tied directly to the object's rotation period. When a particular region faces the sun, jets activate. When that region rotates into shadow, the jets cease. This pattern repeats every 16.16 hours like clockwork. On the surface, this supports the cryovolcano model perfectly. Solar heating triggers sublimation. Ice turns directly into gas without melting first, and the pressure release creates the jets. It's physics, we understand. But here's where it gets interesting. Natural sublimation typically creates diffuse clouds of vapor. The ice heats up, gas expands in all directions, and you get a fuzzy coma around the object. What we're seeing with 3I/ATLAS is different. The jets are focused. They stream out in specific directions from specific points. That suggests there's structure beneath the surface channeling the flow. Chambers, perhaps. Vents. Conduits that direct the erupting gas into coherent streams rather than letting it disperse randomly. How does that structure form naturally? Over billions of years, could fractures in the ice create channels? Could temperature cycles crack the surface in patterns that focus outgassing? Maybe. It's possible, but it requires a very specific set of conditions to create very specific results. And when natural explanations require that many coincidences to work, we should at least consider whether there might be simpler answers. 3. I/ATLAS is getting closer to the sun with every passing day. And if the cryovolcano theory holds, we should see escalating activity. More jets, larger eruptions, an expanding coma as more ice vaporizes. Eventually, thermal stress should start breaking the object apart, just like we've seen with other comets that venture too close to the sun's heat. But what if that's not what happens? What if the jets continue firing with the same precision? What if the acceleration continues in ways that defy outgassing models? What if we detect more course corrections, more anomalies that can't be explained by natural processes? The truth is, we're in uncharted territory. We might be witnessing the first confirmed interstellar cryovolcano, a frozen world from another star system erupting ice as it passes through our cosmic neighborhood. That alone would be groundbreaking. It would tell us that the same geological processes we see in our solar system operate around other stars. It would confirm that frozen worlds are common throughout the galaxy. Or we might be seeing something that challenges every assumption we've made about what's possible. Something that forces us to expand our understanding of what exists in the universe. The data supports both possibilities right now. The jets are real, the anomalies are real, and the mystery is far from solved. Here's what we know for certain. 3I/ATLAS is erupting ice into space right now. The jets are real, the spiral patterns are documented, but the anomalies, the heartbeat pulse, the impossible Jupiter trajectory, the non-gravitational acceleration, those are real too. And until scientists can explain all of it, not just the parts that fit comfortable theories, this mystery stays unsolved. We're watching something unprecedented, whether it's the first interstellar cryovolcano ever observed, or something that challenges everything we thought we knew about what's possible in the cosmos. This is history happening right in front of us, and the story is far from over. What's your take? Do you think this is a natural ice volcano, or are we missing something bigger? Drop your theory in the comments below. I genuinely want to hear what you think, and some of your insights have been absolutely brilliant. If you don't want to miss what happens next with 3I/ATLAS, subscribe to Galactic Breaking News right now and hit that notification bell. We're tracking every development, every new image, every anomaly as this story unfolds. Smash the like button if this mystery has you hooked, and check out our complete 3I/ATLAS playlist to see all the evidence we've covered so far. This is the kind of discovery that reminds us why we look up at the stars. The mystery continues, and we'll be here breaking it down every step of the way. Stay curious, and I'll see you in the next one.